series, a series sequence stuff. So just looking at these two side by side, and at some point I want to do a whole bunch of equations that are in either of these chapters and word problems and see if you can identify what they are. And we'll, spend some time looking at keywords. But if I read this first one, it talks about Colin accepting a job offer with a guaranteed raise of 3%. First things first, when you see something increasing by a percentage, it's either geometric, if you're in the series sequence chapter mindset, or it's exponential growth. Yes? Percentage is growing by a common ratio or by a growth factor. Okay? In the sequence series world, we call it a growth, or in the sequence series world, we call it a common ratio. Back in the exponential growth world, we called it like a growth factor or a rate of growth. So the percentages that give away. Then Patrick has a situation. Oh, see, these were the two names, by the way, I was deciding between when I had my last child. I don't know that yet. But Patrick won, clearly. Well, I don't know if you knew his name. I was bored. My first one is. My second one's Patrick. All right. So in the question, we're going to have one keyword that pretty much gives away whether this is exponential growth decay or whether this is geometric sequence series stuff. Determine how much total each will have made after working at their respective jobs for 10 years. What's the keyword that gives away whether this is geometric sequence series or exponential growth decay? Can't pick on Sierra because I think we maybe talked about this morning. Chloe, what do you think? Because if you're growing by 4%, that could just mean you make your R 0.04 if you're in the exponential growth decay. If that's the geometric series world, that means you'd make your R technically 1.04. So that could be conducive to either. Georgia, what do you think? Total. Total tells you it's a geometric series. Okay? So S sub n equals a sub 1 minus a sub 1 times r to the nth power all over 1 minus r. Now, let's pretend that you thought this was exponential growth or decay. So you would say final amount equals initial amount 1 plus or minus r to the t over p. Okay? If you mistakenly thought it might be this, let's talk about that because that might happen. What is your initial amount? Let's do Colin because he's first. What would your initial amount be considered? 40,000. 1, is it plus or minus? Plus, what would your rate be? 0.03, what would your T be? 10, what would your P be? We're going by 3% every how often? 1 year, right? Okay? The problem is, well, you're going to get an answer, but what does A stand for? Final amount of what? Be more specific. Be more specific to the context of what's happening with Colin's job. That's going to give us, if I type that in, 40,000 times 1 plus 0.03 to the 10th power. That's going to give us 53,756. What is that number? Specific to Colin. That's how much he's making after 10 years of working there. Yes? That's after he's gotten a raise of 3% 10 times. So to be truthful, that's actually his 11th year salary, right? If he's gotten a raise and we've multiplied by this 1.03 10 times, that's actually his 11th year working there if you think about that. Does that make sense to you guys? Because his first year he's making 40,000. He's not getting 1.03. The first time he's getting 1.03 is in the second year. And then in the third year, he'll get another 1.03. So that's actually giving us really the 11th year's salary, if you think about that. Okay? I'm not saying it's easy to wrap your head around that. I'm just saying that's what's going on. That's not what they're asking for because of the word total. So could you do this? Could you figure out his first year salary, 40,000, plus his second year's salary by plugging in a 2? Well, no, you'd have to plug in, this is where it gets confusing. You'd have to plug in a 1 so that he got his 1.03 raise one time. That would give you a second year's salary, and so on and so forth. But that would be crazy. You see total, it's a geometric series question. Now, getting into that a little bit further, a sub 1 is what? Kate. 40,000 minus 40,000. R. What's R? Okay. Here's what's important to note side by side. The R here is different than the R here. This formula has the 1 plus built into it. This one does not. So if we wanted to slow this down and figure out what is our common ratio in this geometric sequence series problem, let's go up here and say, okay, Colin's making 40,000 his first year. Plus, how do you figure out what he's making his second year? So, Natalie, you love it when I call on you, don't you? Everybody loves it when I call on them. It's your moment. Natalie, if you made $40,000 fresh out of college, this is a funny experiment I thought of this morning. If your employer came to you and said, I'm going to give you a 3% raise if you can calculate for me what your new salary would be. And if you get it right, you get your raise. And if you get it wrong, you're still making $40,000. Or worse, you're making less than $40,000. You're making me whatever you think is right. No, but it would be hilarious because I bet a lot of people couldn't figure out what they're supposed to make. That's kind of scary. Your employers could just give you less and you'd never know it. So, Natalie, the question's on you. If your employer says you were making $40,000 last year, I'm going to give you a 3% raise. What's your salary going to be this year? Everyone else, you're welcome to figure out your salary, but wait, we'll wait for Natalie to give first dibs. Beautiful. 41,200. She nailed it. She's getting the raise. Good job. How did you calculate that? So you multiplied, on your calculator you typed in 40,000 times 1.03. Exactly. You know what a lot of people do? Can you guess what a lot of people do wrong? They multiply 40,000 by 0.03 and they tell me they're making $1,200 the next year. That's not right. They're making $1,200 more the next year. So you would then need to add that on to the initial 40,000. Okay? That's what, and you don't need to write this, but that's what this 40,000 times 1 plus 0.03 really does for you. Because when you distribute to the 0.03, you get the $1,200 raise. When you distribute 40,000 to 1, you're retaining that original 40,000 salary. And then when you add them together, now you have your grand total new amount. Does that make sense? So this one has the 1 plus built into it, which is nice. This one does not. So now if we're looking at these two numbers, knowing that this pattern would continue, what's the common multiplier? Now, Natalie kind of already hit the nail on the head with it. A lot of you I know would figure out your new salary by doing the 0.03 first and then doing 40,000 plus the 1,200. So and then some people, here's the second biggest mistake. They tell me that the R is 0.03, and it's not. You're not multiplying this by 0.03. I can promise you multiplying 40,000 by 0.03 does not bring you up. Okay, it brings you down to 1,200. What you're really multiplying by is the 1.03. Yes? So R equals 1.03. Now, let's pretend that you don't want to think about all that. We talked about this earlier on in the chapter. If you want to figure out what the multiplier is moving forward, what operation do you need to do going backwards? Division. So if I do 41,200 and I want to use this method, divide that by the previous term, 40,000, and it will tell me the multiplier that gets me from one to the next. Okay? So if you want to figure out the rate moving, or the common ratio moving forward, do division backwards. So there's a couple ways to think about that I just threw at you. Grab onto whatever makes the most sense to you. So in our formula, we're pretty much done. We have the rate is 1.03. We're adding up the first 10 terms, so n is 10, all over 1 minus the 1.03. And that will tell you what Colin's grand total amount made throughout the 10 years is. Does that make sense? Okay? This problem also wanted you to do the exact same thing for Patrick. And what you notice is that Patrick starts off making less, but his raises are slightly bigger. And so by doing these two series formulas and getting the two different grand totals, you're really thinking long term. Who's got the better job offer long term? I mean, in year one, it's a no-brainer. Colin has the better offer. But by the time we get to the 10 years, the question is, will the 4% raise as opposed to the 3% raise make up for the fact that Patrick's making a little bit less early on? And there's no way to know because, they're kind of conflicting against each other. They're growing at different rates, but other than doing the formula. Okay? Is that any questions on that? And then I'm going to cross this out because that's not going to give us the right thing. All right? On number 8, Nora invests her money into an account that pays 8% interest per year. So again, I see percentage. I'm thinking immediately, and I'm thinking, by the way, I'm looking forward to where your mind will be on the Regents, where there's an equally likely chance it's one of these problems or the other, right? In this chapter, obviously I'm mostly going to be testing the sequence and series stuff, but in the grand scheme of things, you have to differentiate between these two. So you see a percentage, it's one of these two, okay? Per year, compounded monthly, how long will it take for her money to double? Okay, I'm looking for you to identify the key word that's going to help us decide whether it's exponential growth decay or whether it's geometric sequence series. I'd love to see your hand, Jack Birmingham. What? Compounded is the one word. If you see compounded, we have a formula for that. It's on our flashcards. It's not on your reference sheet. Final amount equals initial amount. 1 plus your rate divided by n to the nt power. N has a very different meaning here than it does in our sequence series chapter. In our sequence series chapter, n means how many terms. In our exponential growth decay compounded formula, n means what? How many times it's compounded in a year? And this one is compounded how many times? 12. So your initial amount is, well, we've probably seen this exact same question before. Did they give us an initial amount? Did they give us a final amount? No, but they gave us the relationship between the two, right? We're waiting for this initial amount to double. So if Jason wants to put $1 to $2, that's doubling. If someone wants to put $50 as your starting amount to $100 as your ending amount, that's doubling. If someone wants to put $32 as their initial amount and $64 as their final amount, all of these are fine. Okay? You can make up your own thing, because the reality is the very first thing we're going to do if we're solving for how long? We're solving for t, is divide over a. As long as the final amount was double the initial amount, everyone's going to end up on the same page. It's going to be 2 equals. But when we do that. So your 1 plus your rate is 0.08. Your n is 12 to the 12t power, and this is like a log solving equation type thing. It is hugely important to know that in these exponential growth things, the 1 is added in there. The 1 plus is already in there. So if you see 8%, you use 0.08. If it's a geometric sequence and series question, if you see 3%, you don't use 0.03 probably. You use 1.03. You have to put that in yourself. Okay? That's huge. All right, so I got that point across. I think I did my best. We saw it side by side. Questions on the homework? Going once. Chloe. On the back? Okay. Geometric series says it, point blank, so what formula did you use? No, I got it. I'm just going to copy it from the board. Okay. Did you have anything to plug in for S sub n? No, that's what they're asking. Then the final value of the sum is. So they're looking for this. Do you know A sub 1? What is it? Do you know R? What is it? So you're telling me that they multiplied by 1.5 to get from 54 to 36. I'm pretty sure not. 54 times 1.5 is 81. So now, some rates are easier to see than others. This one, not obvious, right? So if you want to figure out what the multiplier is moving forward, do division backwards. 36 divided by 54 will give you a multiplier of 0.6 repeating, which if we math frac that, 2/3. So there's one issue. Did you know n? What was it? It was 7. They said it. They didn't put it as a number. They put it as a word. 1 minus 2/3. Try that next time and you'll get it. Good? Other questions? Chris Brooks? On the back? Okay. Sequence or series, Chris? And what's your giveaway? Educated on what? Someone, you what's that? Okay, there you go. Let's pretend it didn't. What if it just said, evaluate this? Evaluate. What's your giveaway that it's a series? Very good. Sigma notation is adding up all the terms. So you know it's a series. Arithmetic or geometric, and how do you know? Some of you I know can take this shortcut, but I will have a safe backup plan for everybody else. Elena? Well, it's geometric because this is an exponential equation, right? If it's a linear equation format here, then it would be arithmetic. But it's exponential because it has a base raised to a power, and if it's exponential, it falls as geometric, okay? If you can wrap your head around that, then you can use that and know, yeah, definitely geometric. Fine. But I know not everyone would be in that same boat. So what I will tell you is if you're trying to decide whether it's arithmetic or geometric, just do the first couple of terms by hand. So plug in a 0. 3 halves to the 0 power is 1. 256 times 1 is 256. Plus, plug in your next term. We just plugged in a 0, so plug in a 1. So 3 halves to the first power is 3 halves. 256 times 3 halves is 384. Plus, we have to do one more to see if it's adding the same thing each time or multiplying by the same thing each time. So I plugged in a 0, I plugged in a 1, now plug in a 2. 3 halves squared and then multiplied by 256 gives me 576. So are we adding the same thing each time? This is adding 100 and change. This is adding almost 200. So it's definitely not adding the same thing. Is it the same common ratio? Well, do you guys know off the top of your head 256 times what gives you 384? Because I don't. So backwards, 384 divided by 286, 384 divided by 256, I'm sorry, gives me a multiplied by 1.5. Is that consistent? 384 times 1.5 would give me 576. Is that where I'm at? Yeah. So it is multiplying. There's your geometric answer. So, Chris, we would just use your geometric formula. Do you know S sub n? Do you know A sub 1? Do you know R? Do you know N? They didn't give it to you on a silver platter, but it's pretty easily accessible. You're plugging in 0 all the way up to 8. How many terms will that be? Do the right thing, Chris Brooks. That's why we love you. That's correct. It's 9. So 0 to 8, we find the difference is 8, and then we add 1 to that. Worst case scenario, you're plugging in a 0, a 1, a 2, a 3, a 4, a 5, a 6, a 7, and an 8. That's 9 fingers. Now, you can't count on your fingers if it's going from 37 to 256. That would not be okay. So you want to know the shortcut. Take the difference and add 1. So 8 minus 0 is 8. Add 1 to that. There are 9 terms. All over 1 minus 1.5. You got that, Chris? Well done. All right. Anything else? Haley? Okay. Sequence or series, Haley? Series, sigma notation, good. Arithmetic or geometric? Because here's your formula, and that's exponential. Perfect. So S sub n equals A sub 1 minus A sub 1 times R to the nth power, all over 1 minus R. Do you know your series total? Negative 42. Yep. So they're telling you that the sigma notation equals negative 42. That's their way of telling you you do know the series total. Do you know A sub 1? Not yet, but I can plug it in, right? So the first term I'm supposed to plug in is a 1. So if I plug in a 1, 1 minus 1 is 0. 4 to the 0 power is 1. Negative 2 times 1 is negative 2. So the first term is negative 2. What's R? 4. Now, if you guys don't know that, she got that from the base. And if you didn't know that, you would be able to figure it out if you just plugged in 1, 2, and 3. You'd kind of see what the common ratio is. It is 4. To the nth power, we definitely don't know that. All over 1 minus 4. Did you have that set up or no? You did. Okay, so it's a solving issue. So first things first, I would clean this up by doing negative 2 plus 2 times 4 to the n. We're definitely not multiplying the 2 times the 4. Why not? Right, because the 4 has an exponent attached to it, and we don't want to inadvertently attach that to the 2 also. So, and then it's all over negative 3. So if you're solving by n, the first thing I'm going to do is get rid of your divided by negative 3. Undoing division by multiplying both sides by negative 3. That'll give you 126 equals negative 2 plus 2 times 4 to the n. Next thing I'm getting rid of is the 2, adding it over. Next thing I'm getting rid of is this 2, dividing it over. And then I'm logging both sides. Okay? So log 64 equals n times the log of 4. Divide it, and n, being that it means the number of terms, should always be a whole number. Log 64 divided by log 4. Good? Now's a good time to review something that I still don't think a lot of us are using, perhaps because we still have our calculators in test mode, which, Lord help me, I'm trying to figure out an easy way to get it out of it. Let's see about this one. Oh, this one's good. Okay. So if your base is 4, and you want to cancel that directly without taking the plain log of both sides, I could take the log with a base of what on both sides? Log with a base of 4. If the base of your exponent is 4, and that's what you want to get rid of, if you take log base 4 on both sides, the log base 4 of 4 will just cancel. And then all you need to type into your calculator is log base 4 of 64. Which the change of base formula says that's the log of 64 over the log of 4. That's what we did anyway, doing it the other way. But if your calculators are not in test mode, which your own personal calculator should not be, but if you're stealing one of these every day, it might be. Alpha y equals, go over to function. Sorry, it's not really showing up great. Option 5 is log base. So if I go down to log base, I can actually plug in log with a base of 4 of 64. But again, if you can't do that, the change of base formula says that you could also plug in log of 64 over log of 4, and we all can do that with our plain log button. Log of 64 divided by log of 4. It's the same thing, you just have to know how to type that in if your functionality there is disabled. Okie doke. Okay, anything else on the homework? Okay, pass that forward. Well, you know what? This chapter I used to have, it's like your spiral last Friday. I used to give a sequence quiz, and I used to give a series quiz. My time is limited here, so I don't want to waste it quizzing you. So this one is the series quiz that I used to give. I crossed out quiz and put review on there because I want you to be exposed to those questions. And I did mix in some exponential growth decay. I mean, just scanning the paper, my eyes immediately saw this word compounded. That's not really a geometric series question, right? Does that make sense? That's an exponential growth question using the compounded version formula. So there's that. That's why you have that one. It's just I had it made. I figured why not give it to you. This was the one that's typically the review. I guess before we jump into it, we only have so much time left. Anyone know what time it is? Okay. In general, this chapter is pretty limited. Okay. Now that we've done everything and looking at that thing on the whiteboard over there, I've said from the start, the first question you need to ask yourself, and sometimes it'll be more obvious than others, is this a sequence or a series? And is it arithmetic or geometric? Yes? And once you have pinned that down, you can pretty much just grab the formula and go. Sometimes you'll get your one formula and you'll find out, oh shoot, I need some other piece of information, and you might have to go, like if you choose arithmetic series, we've seen this happen, you go and you know it's an arithmetic series question, but you're missing something that you need. You might need to go back to the arithmetic sequence question for a second, figure out what's missing, and go on. Okay? So that could happen. But definitely classify it first. Just read it, classify it, pick your formula. 3 of the 4 formulas, I'm going to leave that on the board tomorrow. So that is going to be there. You just need to know your own arithmetic series formula, which as a review is your n over 2. And then in parentheses, first term plus last term. So as far as just memorizing formulas, make sure you memorize that. Okay? You've seen compound interest come up, right? I am probably going to assess that different. So if you see that, make sure you also know your compound interest formula. And make sure you know your basic exponential growth formula. Do you remember the other one from that chapter, just out of curiosity? Oh, you guys. The best. They're all final amount equals, and then the keyword for PERT is continuous. The keyword for the top one is compounded, anything other than continuously. And then that one's just basic exponential growth. Okay? And so after we get past the arithmetic, geometric, sequence, or series issue, the only other thing that you need to be fluent with is understanding the notation, how it works, recursive formulas no matter what. Okay? So your recursive stuff is a sub n equals the previous term, and then what are we doing to it? Along with, you have to give some certain value. So your recursive formulas come in 2 parts. So understanding that notation, how to use it, and understanding sigma notation problems and how to do them. Because they will not all be arithmetic or geometric. If the formula is linear, yes, you can use arithmetic series. If the formula is exponential, yes, you can use geometric series. But there are formulas that don't fall into either of those categories, and you have to do them manually, which means you have to plug in whatever number you're starting with at the bottom all the way up to whatever number you're ending with at the top. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Add up those 10 terms manually as opposed to with using a series formula. Okay? So I think this number 1 here, it looks totally foreign. I mean, I can see some subscripts, so I know it's like this chapter. But again, just as is true with the Common Core, not everything is a cookie cutter type question. Okay? You have to just really understand and know your stuff and be able to apply it. So this one says, write an explicit formula for a sub n, and they tell you the nth term of the recursively defined sequence below. So they're taking a recursive formula, and they're telling you, write your own explicit. So I would say, let's wrap our head around what the heck's going on. Our first term is x plus 1. Our second term. How do we get to our second term? The recursive formula says we take the term before and we multiply it by x, right? So if I take the term before, x plus 1, and I multiply it by x, that's what I get. And you can distribute the x through if you want to, or you can just leave it like that. It's a little bit of a bummer because this is pretty arbitrary, given that they're having you multiply by a variable and not a number. That's annoying, but okay, oh well. A sub 3 means you take the term before, this one, and multiply it by x again. So what would it turn into? If I multiply this by x, how's that going to show up? X squared times x plus 1. If you distributed it, Bella, then you're correct. Okay? Now, if they're telling you to write an explicit formula, it has to be arithmetic or geometric. It has to be. Okay? What is this? Are we adding the same thing every time? Or multiplying? Multiplying. So this is a geometric sequence formula we're trying to write. So grab that formula. A sub n equals a sub 1 times r to the n minus 1. And if I'm writing the formula, n stays put. A sub n equals, what's the first term? X plus 1. Because that's a binomial, make sure you keep it in parentheses. What's the common ratio? What's that multiplier? X to the n minus 1 power, and you're done. That's the explicit formula. You'll never know n for the explicit formula. You want to keep n and n so that you can use that formula to find the 100th term if you need. Follow? Next question, for what value of x would a sub n equal 0? Well, if they're telling you that a sub n equals 0, then plug it in. 0 equals x plus 1 times x to the n minus 1. What value of x would make that equal 0? When will this, if something times something equals 0, you can pretty much just tee it up, right? What, if you teed up this part, what would x be? Negative 1. X could equal negative 1. That would zero out the whole thing. Or on this one, what could x equal that would zero out that whole term? What would the base need to be if it was going to be 0? 0. There's no instruction to that other than think your way through it. I mean, that's a top-notch question for, like, if you talk about difficulty level 1, 2, 3, that's a 3. That's very difficult. The review sheet, this one, has your answers, so you'll have those. And then, you know, I really was just trying to expose you to, like, some of the tougher regions questions that we've seen. There's a reason this is on the review sheet, though, and not on the test, because I think it is that difficult. So, you know, don't get overly stressed, but these basic ones, understanding sigma notation and being able to fight your way through that notation. Listen, you guys are big kids. Do what you need to do to prepare for the test. I would recommend doing it all, absolutely, no, hands down. You know, but you're only as good as how motivated you are. Let's say that. Yeah. I'll write that down. All right.